We now join our lesson already in progress. All right, so in this next example, we're going to start solving trig equations that are a little bit more involved. In this example, we're going to solve for theta, where theta is between 0 degrees and 360 degrees, kind of like how we solve an equation in algebra. In this case, we'll add 1 to each side first. Then we'll divide each side by square root of 3. This gives us tangent of theta equals, well, actually I want to rationalize that denominator. So tangent of theta is square root of 3 over 3. Tangent is positive in quadrants 1 and 3. And theta hat is 30 degrees. So the values of theta that make this true, between 0 and 360 degrees, theta equals 30 degrees and 210 degrees. That's our solution set. In this next example, solving for x between 0 and 2 pi, in this case, cosecant squared x minus 2 equals 0. Let's go ahead and add 2 to each side. So cosecant squared x equals 2. Then we can take the square root of each side. Cosecant x equals square root of 2. Oh, but don't forget the plus and minus. We learned that from algebra. So when we consider cosecant x being the positive square root of 2, we're talking about quadrants 1 and 2. And when cosecant x is the negative square root of 2, we're talking about quadrants 3 and 4. In all 4 cases, theta hat is 45 degrees, or pi over 4. And notice we're going to use all 4 quadrants. Pi over 4, 3 pi over 4. In quadrant 3, it's 5 pi over 4. And in quadrant 4, it is 7 pi over 4. 4 solutions. And we're going to include them all in this solution set. All right. Now notice it says there, no solution. So let's take a look at this example that says solve for x. We're going to start by adding 4 to each side. 3 cosine x equals 4. And we'll divide each side by 3, just like we would in algebra. And notice we get cosine of x is 4/3. Now that's an unusual value for cosine. And let's take a look at the graph of the cosine function and see why 4/3 is actually not going to be a solution. Notice that the 4/3, if we draw the line there, is above the graph of cosine x. It's above the 1. So there is no solution. Sometimes we have an expression, a trig expression, that is quadratic in form, ax squared plus bx plus c. And in this case, the 2 cosine squared x plus 5 cosine x minus 3 fits that form. But what we're going to do is make it like algebra and say, let w equal cosine x, so that we can rewrite that as 2w squared plus 5w minus 3. Now I'm going to use my factoring technique, but you can use whichever technique works best for you. That's where I use a product number. 2 times negative 3 is negative 6. And the sum number is the middle value, positive 5. We want 2 factors of negative 6 that add up to positive 5. And those factors are negative 1 and positive 6. Now, as far as the w is concerned, that's really negative 1w and positive 6w. And I'm going to choose one of them. I'll choose the positive 6w to represent the outer product in the FOIL method. What we do is we recognize that 6w is the outer product, 2w squared is the first product, and we take the greatest common factor between 2w squared and 6w. We can factor out 2w from them. And to get 2w squared, the next parenthesis has to be w. And to get 6w, it's 2w times positive 3 at 6w. The last product, 3 times negative 1 to get negative 3. So that's how we get our factored form. We can then replace w with cosine x. So let's practice this. Here we have tangent squared x minus radical 3 tangent x, and we're going to let w equal tangent x. So the expression becomes w squared minus square root of 3 times w. And from algebra we can see that we factor out a w, and we're left with w minus square root of 3. We can then replace the w back with tangent x. So the expression becomes tangent x times tangent x minus radical 3. In this next example, we'll let w equal cosecant x. Then the expression becomes w squared minus 4, the difference of squares. So we're going to factor that into w plus 2 times w minus 2. And then we'll replace the w with cosecant x. The first factor is cosecant x plus 2, and the second factor is cosecant x minus 2. Let's talk about the zero product property. That's if a times b equals 0, then it must be that either a is 0 or b is 0. Let's look at an example from algebra. Let's consider x squared plus x minus 12 equals 0. That happens to factor into x plus 4 times x minus 3. We'll call the first factor a, x plus 4 is a, and the x minus 3 is b. What we do is we set each factor equal to 0. X plus 4 equals 0, or x minus 3 equals 0. In this way, x is equal to negative 4, or x equals 3, and we can write those together as x equals negative 4, comma 3. Well, let's do the same thing for this example here when solving for x. We're going to let w equal cosine x. This expression on the left side becomes 2w squared minus w. And from that, we can factor out w, and we're left with the quantity 2w minus 1. So the left side expression can be then rewritten as cosine x times quantity 2 cosine x minus 1, and they're equal to 0. So we set each factor separately equal to 0. Cosine x equals 0, or 2 cosine x minus 1 equals 0. In the second one, we will add 1 and then divide by 2 to find the cosine value. And we're looking between 0 and 2 pi. So we're looking for radian measures around the unit circle. First, cosine x is equal to 0 along the y-axis at pi over 2 and at 3 pi over 2. The cosine of x is 1/2 in quadrant 1 at pi over 3 and in quadrant 4 at 5 pi over 3. So we have 4 solutions, and we'll write them all down here. Okay, in this example, we have sine squared x plus 3 sine x equals 0, and we'll let w equal the sine x. Then we have w squared plus 3w. By the way, you don't need to let W equal the value. If you can factor without doing the let W equal, that's fine. You just need to be able to factor it correctly. Here, the left side factors into sine x times the quantity sine x plus 3. And they're equal to 0, so we'll set each factor equal to 0. Sine x equals 0, or sine x plus 3 equals 0. The second one needs a little bit more solving, so we'll write sine x equals negative 3. However, it's not possible for sine to be negative 3, so that has no solution for that part of it. The other factor, where sine x equals 0, that occurs along the x-axis. That's at 0 and at pi. So, x equals 0, pi, and we have only two solutions this time. In this example, the left side is quadratic in form, so we'll let W equal secant theta. That left side expression becomes W squared plus W minus 2. Now at this point, I'm going to factor it. You use any factoring technique that you're familiar with that works for you. We need to come up with the quantity W2 times W minus 1, but what we really need to get is the quantity secant theta plus 2 and secant theta minus 1. And being equal to 0, those are the two factors, and we set each factor separately equal to 0. Secant theta plus 2 equals 0, or secant theta minus 1 equals 0. That gives us secant theta equals negative 2 for the first, and secant theta equals positive 1 for the second. So let's see, secant theta equals negative 2, negative in quadrants 2 and 3, and theta hat is 60 degrees. In quadrant 2, that's 120 degrees, and in quadrant 3, it's at 240 degrees. For the second, where secant theta is equal to 1, that happens only at 0 degrees. So we have three solutions. 0 degrees, 120 degrees, and 240 degrees. Okay, in this example, we have something that's quadratic in form almost. Notice, though, it's not yet equal to 0, and that's what we want to get to, so we're going to subtract 3 from each side first. 2 cosine squared x plus 5 cosine x minus 3 equals 0. Now the left side is fully quadratic in form, and we'll let W equal the cosine x. So we get 2W squared plus 5W minus 3 on the left side. Now we actually have factored this already. It's one of the first factorings that we did in this video. This factors into 2W minus 1 times W plus 3. So the left side of the equation becomes quantity 2 cosine x minus 1 times quantity cosine x plus 3. Then we set each factor equal to 0. 2 cosine x minus 1 equals 0, or cosine x plus 3 equals 0. And in the first, we'll add 1 and divide by 2, so cosine x equals 1/2. In the second, cosine x is equal to negative 3. But of course, as we've seen before, that's not a solution. So we'll just focus on the cosine x equals 1/2, and cosine's positive in quadrants 1 and 4. And theta hat is 60 degrees, or pi over 3. So in quadrant 1, we get pi over 3. And in quadrant 4, we get 5 pi over 3. And those are the two solutions. Well, that's all I have for you today. I hope this has made some sense, and I recommend that you review the video as you need. All right, have a good day. See you next time.